In this micro nugget, you and I get to take a look at the functionality, the configuration, and verification of call admission control for IKE Phase 1. Let's begin. In the original flavor of IPsec, which we call IKE version 1, there's actually two phases that systems go through to establish a secure VPN tunnel between the devices. We have Phase 1, and we also have Phase 2. In Phase 1, we're going to negotiate details regarding an IKE Phase 1 tunnel. And an acronym that can help us remember the details of what they're going to negotiate is HAGGLE, which represents the hashing, the authentication, the Diffie-Hellman group, the lifetime, and the encryption that we're going to use. If the negotiations are successful, the second step is to run the Diffie-Hellman that they agreed to during the negotiation process. And the Diffie-Hellman algorithm allows the two devices to establish shared secret keying material that they can use with symmetrical algorithms like AES. And then after Diffie-Hellman is done, the two devices are then going to authenticate with each other using the authentication method that they agreed to in the first of these steps. Now, all of that is part of IKE Phase 1. And if all of that is successful, it can then move on to IKE Phase 2, where we actually set up the IPsec. And it's the IPsec security associations that are going to actually carry transit traffic. Now, as you might imagine, setting up an IKE Phase 1 tunnel is no small task. There's a lot of details that go on. So if an attacker decided to go ahead and try to initiate an IKE Phase 1 tunnel, and maybe he sends hundreds of requests for IKE Phase 1 tunnels. And maybe the attacker is control of a botnet, and now we have thousands of devices all attempting to set up IKE Phase 1 tunnels. Even though they can't complete it, they could put a significant drain on that resource who's willing to try to allow an IKE Phase 1 tunnel to be negotiated. And that would be an example of a distributed denial of service attack. Now, what can we do about that challenge? Well, one method of mitigating that type of a risk is to A, turn off IPsec altogether on the device. However, if we need IPsec, that's not really a workable solution. Or secondly, we could use a feature called IKE Call Admission Control to place limits on our IKE Phase 1 tunnels. And the two major options that we have are, we can say we want to limit the maximum number of IKE Phase 1 tunnels that we can have set up. And the second option is we can specify an upper limit of how many IKE Phase 1 tunnels we're willing to negotiate at any given time. So for example, maybe we say the SA limit is 100, which hopefully would represent the number that we would never expect to get above for our legitimate traffic. And regarding how many we're willing to negotiate at any given time, maybe we set that to 20, which is a rate limiting feature. And with those two commands, the router would say, okay, I get it. As far as IKE Phase 1 negotiations and setting up the tunnels, I'm willing to do a maximum of 20 at a time. And as those become completely fully established, the upper limit is going to be 100. And in this micro nugget, I'd like to give you a quick demonstration of how we could implement CAC and see it in action on a router. So let's start off on R2. R2 is a member as part of a DM VPN network. And let's ask Mr. R2, please show us your current crypto ISAKMP SAs, which are the IKE Phase 1 tunnels, and please show us the crypto call admission statistics. And this will show us what the defaults are because we haven't yet configured CAC. So here's our existing IKE Phase 1 tunnel, which is between R1 and R2. The show crypto call admission statistics shows that the maximum that this device is willing to negotiate at any given time is 1,000 IKE Phase 1 sessions, which is a lot. It's also specifying that the max IKE SAs it's willing to go ahead and have is 0. Now the 0 represents that there is no limit currently in place. However, just below that in the active area, it's showing us that we have one active IKE Phase 1 tunnel, and that's this guy right here. And it's going between 15,001 and 25,002. Now, as a demonstration, I'm going to go ahead and set the crypto call admission limit for IKE SAs to 1, which is way artificially too low. Especially if we're in DM VPN, we might need to have multiple IKE Phase 1 tunnels. However, for a demonstration to be perfect, I'm also going to set the maximum number that this device is willing to negotiate at any given time is 10. Now, Keith, why are you using such a number like 10 if we're limiting the total number to 1? And the answer is, this is the minimum value that we can set for the actual negotiations. But even if we did have 5 or 6 people trying to negotiate IKE Phase 1 tunnels with us, we would only end up with a maximum of 1, because that's what this command is specifying right here. A maximum of 1 IKE Phase 1 tunnel. And I always love to do a before and after approach with commands. Let's go ahead and do a show crypto call admission statistics, and just to verify that the commands that we just put in actually took. So here's our maximum SA of 1, and that is currently right here saying the maximum. And the negotiations are set to 10. That's perfect. Now what that means is if we try to kick in another IKE Phase 1 tunnel, which could be us trying to initiate an IKE Phase 1 tunnel to somebody else, or somebody else trying to initiate an IKE Phase 1 tunnel to us. Even though we're going to be willing to negotiate it, we won't be able to go ahead and set it up because we're already at our limit. So to see what that feels like, let's do a ping from 10.2.2 down to the 10.4.4 subnet. Now in DMVPN, when R2 sees the next hop off of its tunnel interface, it'll do a next hop resolution protocol for that, trying to discover what the interface address is of R4 with the intention of then being able to build a DMVPN direct connection between those two spokes. Our focus, however, in this micronugget is the call admission control portion. So let's test it out. Let's go ahead and do a ping to 10.4.4.4. We'll source it from gig 2/0. And although the pings worked, we did get a message saying, hey buddy, there was an incoming SA request, which implies that R4 was trying to build an IKE Phase 1 tunnel to R2. And it's not allowed. You've already hit your limit regarding call admission control for IKE. Now, unfortunately, because we've hit that limit, all of our traffic from R2 down to the 10.4.4 subnet is going to go through the hub. So we're going to route it over to the hub, and then the hub has to route it back to the spoke. So every time we send traffic, there's going to be another attempt to build that association between R2 and R4. Now, if we wanted to actually verify that that traffic really is being routed through the hub, we could do a trace route to 10.4.4.4, and it should show the hops being R1 at 172.16.0.1, and then to the final destination of 172.16.0.4. And as we sent that traffic, that triggered another IKE Phase 1 tunnel attempt, which got knocked down because we're over our limit. So let's put R2 out of its misery. We'll go back in and let's change the crypto call admission limit for IKE security associations to 6. And check this out. Now if we do an up arrow key a couple of times and do that same trace route, you notice we went through the hub again for that. And that's because the NHRP, the next hop resolution protocol process, it does take a few moments. And then on top of that, there has to be the negotiation and the setup of the IKE Phase 1 and then the IKE Phase 2 between these two peers. And you'll notice we did not get a message saying, sorry, your IKE Phase 1 tunnel has been denied, which implies that the IKE Phase 1 tunnel was built in the background. And after that, the IKE Phase 2 tunnel was built. So now if we did that same trace again, my hands will never leave my arms. I'll press enter, and now the traffic is going directly from R2 straight to R4 over the IPsec protected GRE tunnel. That's part of the dynamic multi-point VPN architecture that R2 and R4 are a part of. I've had a great time. I'm so glad you joined me for this micronugget. I hope this has been informative for you, and I'd like to thank you for viewing.